Welcome back to another video. This will be regarding text-to-CAD. So we're going to take a look at Zoo and how it can be used to generate a Geneva Drive mechanism. So we see over here the rotating drive wheel, the circular disc positioned on top. We have also this pin, the slot for pin, within the driven wheel. Now let's take a look at the models generated using Zoo AI. So we see the prompt over here. Geneva Drive Mechanism, the rotating wheel has a diameter of 200 millimeters. So I can download this. For example, I will download this as a step file. I will go over here and I will drag and drop that from the desktop. So let me move over here to the sides and the following, this will be the step file. So we have it over here, Zoo Text-to-CAD duplicate 1. If I will jump within part design, this will be, as we can see, an assembly. So I will jump within assembly because the step already has those two individual components. If I'm gonna go with the measure tool over here, let's go with this one in order to see that radius. So we see over here the radius is 100 millimeters. That means the AI tool generated this correctly. So the diameter will be 200. This will be for the rotating wheel. So we have this over here. Now I decided to add additional prompt information so that the AI tool can generate this. So let's take a look at this one. So the prompt, design a Geneva Drive mechanism. The mechanism consists of a rotating driver wheel and rotating wheel. With 4 slots, the rotating driver has a cylindrical pin that engages with the slots of the Geneva wheel, causing it to advance in discrete steps. Again, I added that the Geneva wheel will have 200 millimeters with evenly spaced slots, allowing precise motion transfer. Now, we see that this is the output. So again, if I will download this as a stat file, and I will go over here, I will minimize this, and I will drag and drop that newly defined mechanism. We're gonna see that this will be the following. So we have some additional components. If I'm gonna expand, we're gonna have the first one over here. We're gonna have the base, let's make it green, and we're gonna have the other wheel over here. Let's make it yellow. If I will go and analyze over here, we're gonna see that again that radius will be well defined. This will be half, so 15, and we have the overall shape over here, which I should use the linear tool to measure. I can also swap over here directly within CATIA. So we see this will be on a 300 millimeter plate. Now let's see additional inputs. And this will be the following. So over here, I also asked within the prompt to design the multi-cross mechanism as well. So the driven wheel over here. And we see that this will be the output, a total mass. So over here, it was a little bit closer to that. Now, let's see, we're gonna do an input together within the video. Okay, so let me just copy this. I will do a new prompt. And I will specify that it should also design the driven wheel. So design the driven wheel with the slots for the pin. With the slots for the pin. And let's submit this. And I want to leave this over here so you can also see the processing speed, because in those cases it processes quite fast. So we see this is still generating, and while this will process, we're gonna see the output over here. I also want to further discuss and analyze this. So we see over here initially we had those two components. What I like is that each individual component will be separated. So within the step file, we're going to have those. The other file formats will not be CAD friendly, so I'm not sure exactly why the developers designed this. So we see this is ready, and this will be the output. So in this case, by adding that additional information, we see that the output will only be that, let's say it's not really the driven wheel because it doesn't have those cutouts, but it has those slots for the pin. Let's say that those are designed, but we only have 4. We should have 6 slots over here, as we can see. Design the driven wheel with slots. Let's add 6. So let's make one more input with the 6 slots for the pin. Also do the cutout for the circular disc. So let's see like this. Also make the cutout for the circular disc. Maybe the input for this Geneva mechanism, it's a little bit complicated for the AI tool, but this is why I will want to do more similar videos to see how this tool will evolve as the learning process, the machine learning within it will further expand based on the inputs. And also I need to specify that I'm not using any paid account. I'm just using a simple account, and I'm not affiliated with the developers over here. Usually we see a lot of AI generating tools for 3D, and they will all have some restrictions for the basic users. Now, since this is within public alpha, we see that there are no restrictions. And the processing time is quite good, so we see that this is still loading, but as we saw previously, this generated quite fast. Also regarding the input, maybe I should summarize this a little bit better, or I'm sure that it will generate good CAD models for example, gears, a helical gear and so on, and other elements that are directly over here presented. So we see over here a camshaft, a mounting plate that is 12 inches wide, 6 inches tall. Also, the developers are from US. This is why most of the inputs are within inches. But we saw how it also managed to do the models in millimeters at the correct dimension. For example, this input is quite simple, a plate with 4 holes near the corner. Let's type in that, a plate that is 200 by 100 millimeters with 4 holes. Let's specify the radius in this case. Let's add 10 millimeters near the corner, near each corner, and rounded corners. I will not specify the value for the rounded corners and see what this will output. So you see that over here this is still processing. It processed faster for the previous model. Maybe it requires additional time to do those cutouts. Also the circular pattern, have it set to 6, not to 4. Okay, so we have the plate ready. Okay, so this is far from so a plate that is 200 by 100 with 4 holes. I only see 1 near each corner. Okay, so this is quite poorly outputted over here. Let's see if this mechanism will be better defined. I have a feeling that it won't be, so again, if you're gonna see the progress, it didn't have enough information within Geneva Drive Mechanism since the AI tool is not well trained on various CAD models, but I'm sure that it will further improve as it will make use of all of those. But I'm quite surprised that it failed to create this. So let's just prompt this. Okay, so we no longer have that over here. Let's input this. So these are examples that should be, and we see how fast this process, since this was already done by something by someone else. Let's just make this 20 inches by 4 tall. So let's see if this will process. As we can see, this will not process as fast. So this was already processed. So we see this 12 by 6, and this should be 20 by 4. So this should be a lot more longer. And it also takes a little bit more to process, as we can see, since this hasn't been prompted exactly the same. Okay, and we see that this is struggling a lot. We have this, the mechanism is mounted on a sturdy metallic base. So as soon as I also added that within the prompt, we saw how it created an additional part, even though the mechanism is floating over there, but we can have that position over here, as we can see. So let's see if this will process. So as we can see, this doesn't want to process anymore. Or it's taking a little bit longer since I did multiple inputs, not sure. Okay, so we have the mounting plate, and this works as intended. So the aspect ratio we see over here, 20 by 4, and also we have the mechanism. So let's take a look. Okay, and as you can see, this is better defined. It's a little bit odd that we have those holes over there, but we see that regarding the mechanism, some elements of the driven wheel over here are defined. It didn't manage to do the cutout, but overall, I'm quite impressed with the results. Please consider that this is still within alpha version, so it will further improve. Okay, I also encourage you to give this a try, because then the model will be better trained and it will start generating better outputs. So I hope you enjoyed this kind of content. I will position a similar video on the left side, and I will also add a subscribe button to the right. So that's it. Thanks for watching.